I want you to help me build my PC.
You build your PC. I need more information about your preferences and budget.
As you can see, AI market is expected to grow to 47.1 billion by 2030. Can you notice the difference between 2024 and 2030? Alright, so on today's video, I'll go through the whole implementation process of the previous video, in which we have multi-agent system for sales purpose. Alright, so at the beginning, as we have discussed, we have the user message, and then we pass this user message to the orchestrator. The orchestrator is the brain behind your agentic system or any kind of multi-agent system. So the orchestrator receives the user message and then decide which agent to trigger based on the user intent. So within the orchestrator, we have to define our logic in terms of the agent's relevant keywords. So for example, if the user mentioned that he wants to purchase a laptop, so we need to trigger sales agents. But if the client asked to register an event, so we need to trigger Notion agents, and within Notion agents we need to trigger event registering agent. So within Notion agents we have two sub agents. The first one is to create to-do list, and the second one is to create events in Notion calendar. So what I'm talking about is the first step, in which we have the orchestrator that triggers the agents based on your logic. So imagine this scenario with me. Now the user passed a message asking about purchasing a new laptop. So the orchestrator can define which agent to trigger based on the intent analysis. And after deciding which agent to trigger, the orchestrator is going to connect to the API of this agent, which is sales agent. Basically, every single agent has its own knowledge base, long-term memory and short-term memory. And this kind of memory, I will discuss it in a moment. This kind of memory, the first one is the knowledge base, which has all the products that you have, that was the prices, with all the things that the client interested in. And we have long-term memory and short-term memory. Basically, memory concepts in agentic AI is made for storing all the user interactions in order to make the agent evolve over time. So this is the purpose of agent memory in general. And I will tell you what's the difference between long-term memory and short-term memory when it comes to implementation. And also we have orchestrator memory. So we need to store all the interaction with the orchestrator. And I want you to recall the previous example, which is about passing a message from the user asking about purchasing a laptop. So we stored the user ID and we store which agent to triggered with respect to the user message. Imagine this with me. If you have like a message and this message has a certain agent triggered based on the orchestrator intent. So we can track all these changes and we can store it. And in the future, we can like fine tune the orchestrator to enhance its performance based on the user feedback. I don't want to dive deep in this part because it's a bit advanced. What I'm trying to show you on today's video is how to implement this architecture in Python code with the help of Crow AI framework. Before jumping into the implementation, I want you to know about MCP server. Now, as a new paradigm of building agents, instead of defining specific tools for every single agent, we can share the tools using MCP server. So instead of extending this and add tools within it, I just need to call pre-built tools exist in MCP server. And this is really a game changer because you don't need to define all the tools that you are going to use within the agent itself. And it makes the process of developing AI agents much easier because imagine building and specifying, for example, for PC Builder agent, all the tools that this agent may need. So it's going to be time consuming. But now we have the MCP server, which provides all the things that your agent might need. So now we need only to specify the memory and the knowledge base of this agent, and the rest of the things like the tools, we are going to call it from MCP servers. All right, and I forgot to mention this point as well, which is about having centralized orchestrator. And what I mean by saying centralized is you can scale as you want, and this is the biggest advantage of this approach. You can add nodes or agents, in this case horizontally, so you can add a new one there without having any issues like managing the interactions between the agent. Because in my architecture, in which the orchestrator is the brain, all these things are connected directly to the orchestrator, which means that you have to manage all the interactions between these agents within only the orchestrator. And it means that by adding new agent, we are not going to change the logic of the rest of these agents. And it's quite tricky. It makes life much easier because we need only to customize the orchestrator when we add new agent. So imagine the alternative approach in which you manage all the interaction between these agents. So you have like, let me show you this in a simple way. You have like logic from Notion agent toward this sales agent, and you have logic from sales agent to, you know, kind of BC builder agent. You have all these interactions, and once you add new agent, you have to change all these interactions. So imagine having system with tens, with 100 agents, and adding one agent means that you have to change all these interaction logics. But with orchestrator approach, you don't need to change the interactions because you don't have interactions between the agent. Even if you have these agents are able to collaborate in certain tasks, the orchestrator is able to send a request to this agent to execute certain command or to execute certain instruction, and then receive the output and then manage the interaction between these agents without any inner interactions within the multi-agent system. And this is the beauty of orchestrator-based approach. So without any further ado, let's open this project that I've built. So CMD, and then I will use Terra, which is AI editor. It makes life easier because you can use AI for pretty much everything and for free. So let's click enter to open the project. So takes about time, and here we go. All right, so this is the project. As you can see, let's close all these folders to show you the architecture. So first we have folder with agents that store all the agents code files, and we have the front end, which is, you know, a cool interactive UI that makes you see your voice wave and all these kind of interesting things. And we have orchestrator, which manages all the interactions as usual. Oh, okay, sorry. So, okay, let's close this again. Let's close this again. So we have agents, orchestrator, and this create database just for creating a demo or just to create a virtual database to be able to use and to check and to test my multi-agent system. Anyways, first thing first, in my approach, which is about having centralized orchestrator, is about having these agents can run independently. So let's test PC Builder agent alone without any integration in my system. So you can run this agent independently based on the agent's memory and based on the agent's knowledge based. So as example, so where's the main file where you have BC Builder agent? We can go and run it independently. So yeah, it should ask me the question now. Okay, so the agent is asking me, what is your budget for BC Builder? I'm running BC Builder agent only without any kind of integration. And this is the first rule. This is rule number one, is to have your agents independent, which means that you can run each single one before integrating it in your system. So before adding this agent in my architecture, I tested it independently. I tested the output of it. I tested the memory. I tested the retrieving process. So it is a matter of scalability, because if I want to add a new agent, it's going to take 5 minutes. I'm not exaggerating. In this architecture, adding horizontal agents is much easier than any other architecture. So I would say $1,000 and then press enter. And then the agent is asking, what's the primarily be using, or what will you primarily be using this PC for? So I would say programming, because I'm a programmer. Programming. Press enter, and then it is asking me about the CPUs that I want to use. And this agent basically has knowledge of the CPU, GPU, motherboard compatibility. So as you know, the CPU using Intel CPU is a bit different than using AMD CPU when it comes to the GPU compatibility and motherboard and all these things. So this agent basically is designed to help the client build their own PCs in a compatible way. So I can't take this with this, or I can't take this with that. So it is asking me about, I will say Intel, like this. And then it will keep asking me questions until it makes sure that all my requirements are compatible, and then it's going to suggest the product or the set of components that I'm going to use. So this is the first concept. The same concept goes for the rest of the agents. You can use all these agents independently. Let's discover how I've implemented these agents. So let's start with, let's say, sales agent. All the agents has the same architecture in which you have the API that you can use for external access. So let's imagine that you deployed this agent in Vercel and deployed it BC Builder agent in another platform or another deployment platform. So you can manage all these interactions with the help of the external API. So it's quite important to define your API when it comes to AI agents, because you may need to deploy these agents in a different platforms. So you can manage and gather data and send data from these agents using API basically. And for this purpose, I've used the fast API, but let's discover this architecture of one agent, and the same concept is going to work with the rest of the agent. First, we have our imports because we need to provide context. So we are including or importing the short-term memory and the long-term memory as well. We importing the SQL SQLite to import or to read the knowledge base that we stored it in this .db file, in which we have like these fields. This is the name of the product, the ID, category, price, description, features, and the stock or the availability. So you have to specify all these things based on your logic or based on your use case. But anyways, Crow AI makes life easier. So as you can see, we have mainly agent, task, and the Crow. And this is the very fundamental concept of AI agents when it comes to Crow AI. So first, I define this agent in a class called sales agent, in which I have this constructor or the initiator that initiate the basic information about this agent. We have the self, which is point to the current scope within the same brackets of this class. And we have name, rule, goal, and the backstory. And we are just assigning this variable. It is I think you know about this concept of constructor, in which you want all these things to be initialized once you run your agent. And the second one is the execute task. We have the task and we are assigning this context false. And basically we are connecting to our database or our knowledge base, in which it has all the products and the prices and description, etc. And what we are doing now is basic SQL command, in which select all from products. So this is syntax or SQL syntax, and it simply says select all from products. And we are assigning knowledge base to this database content, which is products. And then we are iterating through all these things that we have, which is ID, category, description, and the stock or availability. Because we need to cover or to, have all the context to be able to interact with the user and answer users' questions. And we are assigning the model that we are going to use, which is Gemini 1.5 Flash. It's free to use. You can get your API key from Google AI Studio. It's 100% free. And we are just telling the Gemini LLM that this is the knowledge base, and we are passing our context, which is the product name, category, and all the things that we are iterating through it, to Gemini 1.5 Flash LLM to be able to use like retrieval augmented generation, which is RAG. So simply in RAG, it's a very well-known concept in AI. It is about having database or knowledge base, and then we are using LLM to retrieve data from whether you are encoding these data in vector database or in graph representation. And after answering the user's questions, we need to provide extra context to the LLM to generate the next questions. So we have like sequence of questions. So the user answer first question, and based on the first question, the LLM is going, or the agent is going to ask the next question based on the previous one, and so on. So we have this method right there, which is generate next questions, and we pass the answer of the user to this function because the next question is going to depend on the previous question. So it's kind of providing context to the agent to have like relevant questions. So we are creating new variable, which is connection to the knowledge base using SQL3 method to be able to connect and retrieve our data from the stored data there. And we are applying the same command, which is select all from products, to be able to have all the features or the columns that we have in our database. And we're just providing this context about the fields or features of our database. As we can see, stock and features, category, description, and all the rest of the things that I've mentioned. And we are closing this connection after retrieving all the information that we need. And then we are calling again the Gemini 1.5 Flash model, and we are providing this prompt to the LLM. So we are saying you are friendly sales assistant helping a customer to find the perfect products and so on. As you can see, it's the prompt, the text prompt. And by the way, you can implement something called it prompt tuning, in which you may have more than one prompt and you are playing with these prompts based on some parameters. So yeah, you can provide more prompts based on some parameters, and you can implement prompt tuning. But anyways, so we are providing this message to the LLM, and we are providing the context that we have collected above about the user messages and the corresponding answers. And simply, if we have zero context, we are going to print this, nothing yet. So we are providing this message if we have null context. Anyway, after passing this to the LLM, we are storing the response of the LLM in this variable, which is response, based on the prompt that we passed. And we are assigning a question to respond to text, to get only the text without any, special keys or special characters. And now we are defining this method, which is run sales agent, and we just using the methods from Crow AI framework, which makes the life easier. As you can see, we have this object, which is agent equals sales agent, that we have defined it in the constructor above, if you can remember it. And we're just assigning some metadata to this agent, which is the name of this agent, the role, the goal, and the backstory. And then we are initializing the memory that I have talked about, which is very important for your agent evolvement. And then we are assigning the task with the description and executed output, which is a clear and concise product recommendation. All this metadata is going to help your agent to work in a proper way. And then this is the most important part in Crow AI, and it's from its name. It's a crow. So you are using Crow AI, and you have Crow. Crow object based on Crow AI framework is about allowing multi-agents to collaborate in order to do certain tasks. So as you can see, we have agents variable, and we are passing our agent in this list. It's a variable or list variable. And we are assigning the tasks that we have defined it above in tasks list or list of tasks. And this verb is equal true, which means that we are getting looks while the agent is running. But in this scenario, I'm not utilizing Crow object because, as you can see, the purpose of Crow object is to pass multi-agents within this agent's variable and to pass many tasks within this tasks list or variable list, right? In my case, the orchestrator is managing all these interactions, right? So you might utilize this feature in your logic. But in my case, in which I'm trying to prove that orchestrator approach is going to be much scalable than any other approaches, I will not utilize these features. But this Crow features is absolutely great. I'm not saying that it's not useful. No, nothing is right and nothing is wrong in the agentic AI world? It depends on your scenario or your use case. So I might discover or I might use this feature in the coming projects. I might use it. Why not? So you have always to reflect to your scenario or to your problem, right? Make sense? So it's time to define some questions, keywords, like the budget, the usage, the preferred brand, features, and size requirements, right? And before talking about this while loop, 100% AI is making this process of making AI agents much easier. So now I'm using Terra AI editor, and you can open this terminal, and then you can open a new chat, and then you can provide the context, which is workspace, and start to ask the questions about this project, and then you can edit something with small or with weak knowledge. So AI is changing the game forever, but you have to understand the architecture, like this architecture that I was talking about. Understanding these things and how these things are working is important. And after deciding what's the approach that you're going to use and what's your agents and what's the logic behind the agents and what's the things that you need and the things that you don't need, you can then use AI to write your Python code. So I'm not saying that all these technicalities you have to be aware of. No, I have spent 4 years in computer science learning about these things, and now I'm not using it quite often. So AI is making the process much faster, but first you have to find the problem, break it down in smaller agents, and start to write your code using AI. But first, build the mentality that makes you solve the problems, because the purpose of AI agents or agentic AI in general is to solve problems, and then you will get paid. And AI is going to help you, or is going to accelerate the process of writing the code and building these agents. But first, you have to solve it on paper, or you have to solve it like this way. Anyways, in this while loop, while true means that we are going to iterate infinitely unless we break this iteration using break keyword. The purpose of this while loop is to ask the questions in dynamic way. So if the agent is still running, this while loop is still working and is still allocating and getting all the keywords, and then assigning the next question to generate next question that we have defined it above, and then next questions dot upper equal and then we are getting the answer of the user based on the questions that we have created or that was generated using the LLM, and then we are reflecting to the short and long-term memory. And I will show you how this kind of memory was built in Python in a moment once I done this sales agent main Python file. So anyways, I'm pathing the answers to the short-term memory and long-term memory, and I will show you the difference between the two. These two kinds of memory are quite important, as I mentioned, for agent evolvement. Anyways, I will talk about this in a moment in more details, but skip this for now. Now, based on the questions that the agent is going to ask or the agent already asked, we have to receive the user's answer and then analyze it with the help of the LLM that we are using. So the user might say something which is irrelevant, so the agents can't answer this question. So we are handling this by this prompt. So we are saying, analyze the following user response to the questions, and we are providing the question, and then the user response for this questions was answer. And then we are asking the LM, oh LM, is this a question expressing something that you can't understand, or asking for help, suggestion? So we need to know whether the user is answering the right answer or just saying something which is irrelevant. So it's a kind of intent analysis, because not every answer is going to be valid, and not every answer is going to have like right context to generate the next question. So it's quite important part, and I think it's obvious. So we are doing this to decide whether the user want help or not. So if help or if need help, which is Boolean, that is stored true and false. So if needs help equal true, we are going to enter this if statement. All right. it's now the time to talk about the concept of long-term memory first. So first, long-term memory is designed to have consistent and persistent memory storage. So it is long-term memory because it stores all the interactions between the human or the user and the agents. So for a given instruction, the agent triggered this, or the orchestrator triggered this agent, and the response of agent was X, and the question was Y. So we are tracking and storing all these interactions, which is important for the agent evolvement. So at the beginning, we have this class, which is long-term memory, and we have this constructor that defines all the things that we are going to need, like the base directory that we are going to store the JSON file that's going to hold all these interactions. And we have the file name basically, and this load to be able to load these kind of tracked data into the JSON file. And we have first function, which is load function that check whether the file exists or not. And we have this remember function that takes key and value to be stored in the JSON file that is going to be created. And we have the recall method that takes the keys in order to call the preference based on this key. So for the input key, or for the passed key to this recall function, based on this key, we are going to have certain preferences. And simply we have this all preferences function, which is returns dictionary that holds all the tracked preferences. And basically save, function to save, and function to clear. And as I mentioned, the concept behind long-term memory is to track all the interactions in order to make the agent evolve over time. But when it comes to short-term memory, it's a bit different. Short-term memory basically is running while the app is running or the program is running. So in case of I'm a new client talking to the agent is going to start new short-term memory for me specifically to track all the interactions for only the chat between me and the agent. And once I close the thread between me and the agent, this file is going to be deleted. But it's important to track all the messages and the responses while the agent is working. But we don't need to store this when it comes to short-term memory. But we can handle this in long-term memory if we need, because no need to store all the interactions in every single case or every single interactions with the agent. So it's a matter of the use case itself, but I'm just discussing the concepts behind long-term memory and short-term memory. So at the beginning, first, we are initializing new empty dictionary, which is preferences, to be able to track all these things during the process of talking to the agent or interacting with the agent. And we have remember function, as we saw in long-term memory, which is track key and value. So the key is associated with a specific value. And then we can recall the preference based on the given key. We can call the associated preference or preferences. And at the same way, we have all preferences to retrieve all the interactions within the thread. Once the thread is done, or once the program is stopped or the conversation ended, this kind of memory is going to be deleted. So it was only about one agent, and the rest of these agents implemented the same way, in which we have the logic of the agent itself, we have long and short-term memory, we have the external API to be able to access it from anywhere, and we have the knowledge base. So it's a kind of generalizing the process of making agentic AI system, or to be specific, to the process of making multi-agent systems. This is the process. You have agents, and you have to map the logic between these agents, how these agents are collaborating, how these agents are interacting with each other. All these things you have to specify in the orchestrator, because it's the brain behind the multi-agent system. So let's close all these folders and start the demo. So first I have this path file, which is made to run all the agents by only typing one command, and as well it runs the front end. So as you can see, we are just running these agents as separated APIs. So we have API for every single agent. So for example, if I want to run, or I want to start the server of sales agent, I can just type this command there and then press enter. And then now the sales agent is running in the server. or running as a server in which we can send requests and receive responses. And the same concept goes for the rest of these APIs. So we can directly run all these agents by typing this command in which we have run all.pat and then press enter. And as we can see, it opens the terminals of every agent as these
Welcome
agents.
to our tech store. I'm your virtual assistant. How can I help you today?
And this is the message. So I will just comment these commands or these instructions that starts the user interface because I want to test the agent from the terminal with you. So let's comment this and then let's run the APIs that we have for the 4 agents. So I'll type run all.bat and then press enter. All these agents going to start now. All right. So I can go to orchestrator and then run this this code file.
Welcome to our tech store. I'm your virtual assistant. How can I help you today?
Okay, I want you to help me to build a PC.
To help you build, I need more information about your preferences and budget. However, based on the database, here are a few compatible options.
All right, so I want to register a visit to the stock tomorrow at 2 p.m. So now let's test the agent triggering mechanism. So I will say to the agent that I want to register and visit to the stock, and I will ask the agent to register a visit to the store, and we are going to see. So first I will say I want to book a visit to the store, let's say after 2 days at 5 p.m. and then press. So as we can see, it switched to Notion agent and it has to map all these. So yeah, status success, a message created, event visit to, and this is the date. So now I have to go and check my Notion. So simply I will go to Notion. I will log in with my account, login. So we have this calendar events within this page, which is and then we have, as you can see, it's a visit to the store. And the agent can understand that after 2 days means 2 plus the current dates. Now so it gives me May 4. So it can map all these natural language into numbers with respect to the current context, which is calendar or timing, etc. So let's check another routing or another agent triggering. So now the status of booking the event is success. So let's try to, okay, I want to buy a new laptop. So can you help me in this? So yeah, it's now switched to the, as we can see, where's the message? Switch to sales agent after passing this message. So orchestrator can dynamically assign and reassign tasks from and to the agents currently available in agents folder, and we just have to map all these interactions within orchestrator without any need to specify any inner logic between these agents. And this makes this architecture is very scalable. We can add as we want agents, and we just need to map all these interactions within the orchestrator only. And as we can see, it works well. And now after passing the message, we have, after saying, I want to buy a new laptop, so can you help me in this? Now it is start to suggest laptops based on the knowledge base. The knowledge base isn't that huge. It's very limited. I just built it for proof of concept. So yeah, I think you got the idea. And basically you can run this with the voice mode. So we can close all the things. We can close all the open terminals. You can see and run it again after activating these commands because I stopped it to test it in the terminal. So let's save this and then run it. So I will say run all.pat and then press enter. So it will open all these things and will run the user interface, which is this mode.
Welcome to our tech store. I'm your virtual assistant. How can I help you today?
Okay, so I want you to suggest a new laptop for me. Can you?
Based on your request for a new laptop, I suggest the Ultrabook Pro ID 1 for high performance or the Budgetbook ID 4 for a more affordable option.
Okay, thank you, man. Okay, can you help me, let's say, purchase the perfect laptop for my need? Can you discuss this with me?
Please provide the user's request. I need the user's preferences or needs to give a product recommendation.
I want you to help me build my PC.
You build your PC. I need more information about your preferences and budget. However, based on the provided database, here are three compatible CPU combinations. 1. Intel Core 12700 plus NVIDIA GeForce RTX 3060, a strong combination for gaming and general use. 2. Intel Core 10900 plus NVIDIA GeForce GTX 1080, a powerful option. The GTX 1080 is an older card, the Ryzen 5 5600X plus AMD Radeon RX 6800, a good balance of performance and price. To give you a more specific recommendation, please tell me your budget. It will help narrow down the options. Primary use case.
So I want you to help me to build my PC. I want you to help me build my PC.
To help you build your PC, I need more information about your preferences and budget. However, based on the provided database, here are three compatible CPU combinations. 1. Intel Core 12700 plus NVIDIA GeForce RTX 3060, a strong combination for gaming and general use. 2. Intel Core 10900 plus NVIDIA GeForce GTX 1080, a powerful option, though the GTX 1080 is an older card. 3. AMD Ryzen 5 5600X plus AMD Radeon RX 6800, a good balance of performance and price.